Point two, it's important to think in a certain type of a way when it comes to standard deviation and when it comes to variance. Here's a reminder. When you were in geometry and you had a right triangle and you had two legs, 5 and 12, and you were asked to find the hypotenuse of that triangle, how would you find that hypotenuse? Would we just add 5 plus 12 to get 17? No, we wouldn't do that. Instead, you use the Pythagorean theorem. And mathematically, it simply works, and there's ways to prove this, but 5 squared plus 12 squared equals c squared. And later in this lesson, variance is going to work in the same way, where we can't add standard deviations, but we can add variances. Just like here in the triangle, we can't add the sides, but we can add the squares of the sides. And then in the end, take the square root to find out that this side is 13. We'll get back to this in just a minute. For now, why don't you look at the blank copy of the 6.2 notes and example number 3, read it to yourself and press pause, and when you're done, we're going to go over the problem. Okay, now that we're back on this one, if you take a look at this, I've drawn up some notes and I posted those notes on Schoology. So in Schoology, if you click on the 6.2 intro right here, you'll get the same notes that I'm speaking from right now. And those notes look like this. First off, they told us that you have a single apple, and they tell us that the weight of the apple, the average weight of a randomly selected apple is about 9 ounces. Now, apples don't come the exact same weight, and they vary. And so this is the average weight of a typical apple that is picked is 9 ounces. And the typical variation among apples, if you randomly picked a different apple and you looked at its weight and you picked a different apple, you'd get variation of about 1.5 ounces is typical. They tell us that the distribution of the weights of single apples is 9 ounces, is normally distributed with 9 ounces being the center and 1.5 being the spread. Now that's just one apple. And we're letting the letter A represent the weight of one apple. But this question asks us about the weight of a bag of apples. So this is, what do we do when we have information about a single item, like one apple, but now we're going to put them all together in a bag? So if you can think about it right here, here's a bag of 12 apples. And if I asked you the question right now, the question that we're asked is, what's the probability that the weight of a bag of 12 apples will be less than 100 ounces? Well, we know each of these apples is about 9 ounces, give or take. So how would we find the predicted weight of about 12 apples? How would we find the center of this distribution? And this distribution, let T be the total bag weight. So what's the weight of this whole bag on average? How would we find that out? Well, if your intuition was telling you this, to get the total weight of an apple, we just add the first apple plus the second apple, so this apple plus this apple plus this apple plus this apple. So we would expect the first apple to be about 9 ounces, the next one to be about 9, the next about 9, about 9. And if we had 12 individual apples, 9 times 12 puts us at 108 ounces for the center. That would be 108 right here in the center, letting T be the total weight of a randomly selected apple. So for the centers, you just add them all up in this case. It's not a big problem. The tricky part comes with this standard deviation T. When it comes to the standard deviation T, this is kind of like the Pythagorean theorem I was telling you about. We cannot just add the standard deviation of the first apple plus the standard deviation of the next plus the next. Standard deviations don't add up, just like the sides of a triangle don't add up. But the variances do. The squares of the standard deviations do add up. So here is the formula then to find for this whole bag of apples. The variance of the whole bag is the variance of one apple plus the variance of another apple plus the variance of the third, and so on. We would have 12 apple variances total in this. So what are we going to do? We're going to put in the variance of one apple is 1.5 squared, because that's what variance is the standard deviation squared. So if we did 1.5 squared plus 1.5 squared plus 1.5 squared, etc., we would have 12 of these 1.5 squareds, 12 of these variances. And if you did that on your calculator, you should get 12 of these 1.5 squareds should give you 27. You should try it on your calculator to get that. And that's what the variance is 27 ounces squared. But if we wanted to know that what the standard deviation is of this bag of 12 apples. So what we're going to do is we're going to take the square root of the variance and find out that the standard deviation is square root 27 ounces. So now we have found out for this whole bag of apples, we expect it to weigh about 108 ounces, and the bag is going to vary because not all these bags of 12 apples is going to weigh the exact same. They're going to vary, and that variation is going to be varying by about the square root of 27, which is like a little bit more than 5 ounces or so. So what's the probability that the whole bag will be less than 100 ounces? Well, if I put all the information into my normal curve for the bag is about 108 ounces, give or take about 5 ounces or so. When you do the square root of 27, you'll see that it's about 5, a little more than 5. And so to get to 100 ounces, it's a little more than 2 standard deviations below the average of 108. So it would be a z-score of negative 2.1 or something like that. So we're curious about what is the likelihood that a bag of apples that's randomly chosen with a bunch of random apples in it is less than 100. And since it's a normal curve, we can just say the probability that the total bag weight is less than or equal to 100 ounces is normal CDF of negative a billion to 100 with an average of 108 and a square root of 27 gives us a probability of about 6.183%. So if you were making bags of apples, if you were an apple manufacturer and you were putting 100 ounces on this bag, you said this bag weighs 100 ounces. Well, just based on how the apples vary, about 6.18% of the time, your apples are going to not weigh 100 ounces. They're going to be less. And that would be a problem because that is happening more than 5% of the time. So that would be an issue for this manufacturer.